Hello everyone, welcome to the indices portion of our surds and indices topic from the Year 10 syllabus. Now, I'm going to revisit an idea that we looked at in the previous year's content when we explored fractional indices, and we're going to take this one step further to uncover the final index law that we need to cover. And once we've done this, we have effectively gone through everything, which is going to give us the building blocks to working with more abstract questions, which we will address in the next video. Now, from last year's content, you may remember, if you don't, or if this is brand new to you, please go back and look at some of those old videos. We came up with this particular relationship here, that when we had fractional indices, and we always worked with a numerator of 1 with those questions here, this gave us a particular relationship where the denominator here ended up being whatever degree of root we had on the surd. So our fractional indices gave us a link between indices and surds. So if we had, for example, let's go 3 to the half, we wrote that as, okay, that can be the square root of, let's do a nicer number, that'll give us a nice answer. Let's do 9. If we took 9 to the power of a half, that gave us the square root of 9, which you may remember we can either write it like this, but in shorthand we typically write it like this. The square root of that number 2 over here is implied. Now, taking the square root of 9, that just gives us 3. We also did stuff like this. For example, if we had 8 to the power of a third, well, I can write that as just, well, we have a root of 8, and the number here, the type of root we're taking, depends on the denominator. So this is going to be the cubed root of 8. So the number that multiplies by itself 3 times in order to give us 8. So something times something times something, that being the same number, that is what we're going to multiply to get 8. So taking a cubed root is the reverse operation to cubing something. And here we know that this is 2, because 2 times 2 times 2 gives me 8. Now, this is a really good starting point. And I'm just going to give you a little hint as to what we're going to be doing in this video. One thing I haven't written here when we looked at our fractional index law is that a thing that is implied is if I just have my a on its own, that is like saying a to the power of 1. Okay, just going to leave that there. We'll come back to it later, because right now I want to explore with you what would happen if we had something like this. So instead of a 1 here, I've just put this m to just represent any number that's not 1. Just some other number, any number other than 1. Okay. Because we're going to see what the effect of something like this would be. Now, like with most of the videos, if you don't really care about how we got to the formula or the relationship that you see in your textbook, feel free to skip this and just go into some examples later in the video. But if you really want to get an idea for how this works, you can feel free to join me in this particular section. Now, what do we have here? I have a to the power of some kind of fraction. Now, I want you to have a think, is there any way we can get this fraction using anything we know about indices or index laws? If we can get this fraction to something like 1 over n, which we're used to. Feel free to pause the video if you need some time to think. But going into this, I can actually write this thing as a to the power of 1 over n to the power of m. Now, why can I write it in this way? And why should I write it in this way? Well, I've done that because now I have a relationship that I know already. What happens when I get a fractional indice with a numerator of 1? Well, I just know already how to relate that to a surd based on what we had up there. And the reason I can write the m outside of it is that what we have here, from what we've learned in our previous index laws, this is a power of a power. Now, what happens when I have a power of a power? Well, those two powers just end up multiplying. So these two end up multiplying. I've just deconstructed this a to the power of m over n into something different, which is going to help us. Now, just so we can clarify how this works, 1 over n times m is the same as 1 over n times m over 1. We're taking a fraction of a quantity, so we know that this guy will just get multiplied up on the numerator. So we end up with m over n. So this deconstruction works that we've come up with here. But now, let's see what that actually means. So what we're doing here is I can write this in two ways. These are interchangeable. I can write this as a to the power of 1 over n to the power of m, or I can also just write this as a to the power of m to the power of 1 over n. Now, what that means now is that I have a way I can express this now. I can write my guy on the left here as, well, the a to the power of 1 over n. From our relationship before, well, we just know that I can write this as the nth root of a to the power of m. Or I can also write this as a to the power of m, and I'm taking the nth root of that. These two things are exactly the same. Let's shift this along a little bit. These two things are identical, because if I were to take the power here, well, I would still get something that equals to this right-hand side. So what we've essentially established is a new index law, which is that when I have a to the power of m over n, now these m's and n's, they're just algebraic terms. They just mean any number. This will work for any number. I can write this as a to the power of 1 over n to the power of m, or I can write this as the nth root of a to the power of m. This is the exact same thing, and this is a way now I can write these fractional indices. Now, why did I actually end up writing that 1 over here? Well, that was to show you that this law that we just came up with still applies to the fractional indices we learnt about before. A to the power of 1 over n, I can write that as, well, a to the power of 1 over n times 1, right? Because 1 over n times 1 is just another way of writing 1 over n. And that gives me Also, a to the power of 1 to the power of 1 over n, which I can now also just write as, well, I'm taking this entire expression to the power of 1 over n. So I can express this as a surd to the nth root of a to the power of 1. Or, I know a to the power of 1 is just a. So this same relationship, this same index law still applies to what we learnt so far in this case here from last year's content. But we just don't really do it in the long way because we don't have to, right? We already came up with a relationship for that. But now when we're considering other numbers, we need new ways of approaching these types of questions. Now, let's have a go at a few examples. We want to express the following in index form. And let me just put a nice big red box around the main key idea from this video. This being how we can express these types of fractional indices as surds now. Okay, let's try some trickier ones for the practice questions. We have 3 multiplied by the 4th root of x to the power of 7. Now, we need to determine which of these numbers goes where when we write this as a fractional indice or an index form. And also, a multiplication here is implied. So whatever this fractional, this number in index form is going to be, that's just going to get multiplied by 3 at the end. But working with this expression here, if we look back to our relationship that we established, the root, the degree to which this number is getting rooted, ends up being the denominator of my fraction. And the number here ends up being the numerator of the fraction. So this is like saying 3 times x to the power of, well, my 4 goes on my denominator, that's the degree to which I'm rooting this, and my 7 goes on the top here. So I get 3x to the power of 7 over 4. And that is my answer. I've just taken something in surd form and written it in index form. Because remember, fractional indices relate surds and indices together. Now let's look at one more, and then we'll do the next part of the video. So we have 10 root 10, or 10 times root 10. Okay. And we want to write this in index form. So my square root of 10, I can write, well, let's leave this 10 out the front here. I can write this as 10 to the power of 1 over 2. There's a 2 on the denominator because we're taking the square root of 10, and there's a 1 on the numerator because there's no actual power, there's no non-1 power up here. It's just 10 to the power of 1. So that still goes on the numerator, like in the previous question. And now we're multiplying here, same base indices. I'm multiplying 10 to the power of half by 10 to the power of 1. So, doing these, it's going to give me 10 to the power of 1 plus a half, which gives me 10 to the power of 3 on 2 in its simplest form. In its index form, collecting the like bases and applying our index laws from before. Okay, let's look at another set of questions. Now we've done some work with writing things in index form. Let's go the other way. So let's start going from surd form. From index into surd form. So we have here 3 to the power of 3 over 5. I want to write this in surd form. Now, all I need to do is consider the denominator, where that's going to go, and my numerator, and what that's going to represent. And what tells us that is the final index law we came up with. The denominator ends up being the root here. And the numerator, let's color code that a bit better. The numerator ends up being the power. Now it can either be the power there or the power in here. It's the exact same thing. So now my denominator is 5, so I'm taking the 5th root of 3, and my numerator tells me the power I have here. I'm taking the 5th root of 3 to the power of 3, or I can write this as the 5th root of 27 here. Cool. Let's do one more question. Let's do 5 to the power of 2 over 3. I'm doing the exact same thing here. I'm just considering, okay, what my denominator is and what my numerator is and where those are going to go. My denominator is 3, so that means I'm taking the cubed root, and here I have 5 squared in here. Now, if we wanted to do this the long way as well, this is like saying, for example, 5 squared to the power of 1 over 3. This means the exact same thing. My power here, 1 over 3, means that I'm taking a cubed root, and my 5 squared down the bottom is the number I'm cubed rooting. So we get this thing here. And now, to do this, we have one more step. That's just to write what 5 squared is. So I'm taking the cubed root of 5 squared, which is going to be 25. So that is our final index law with fractional indices. And this is how we can now work with these numbers on the numerator that don't equal to 1. All of the ones we did in the year 9 content equaled 1. It'd be 1 over 3 or 1 over 5 or 1 over 2. Now we have, through some manipulation of our indices, using our power of a power rule, so this guy up here, relating that to this thing here, which we have done earlier in this video, that is now how we can work through our final index law for we'll call this further fractional indices. But thank you so much for joining me, and I'll see you in the next video.